Alright, in this video we're going to be taking a look at area between two curves. How do we find the area? So if we look at given functions, so in this case we have two functions and we want to find the area between them. So that would be this area right here. So if we were to look in between these two curves, what is that area? So you may remember how to do this, but this is just a quick reminder of how we find the area between two curves. So the first thing that we need to really know is where do we start and where do we stop? So we know as calculus students to find area under a curve, that's going to be an integration problem. So we need boundaries. So if we were to look at the graph, we could easily find where the intersection points are, or the boundaries of the two curves. So this would be one here at x equals -1. This would be on the other one over here at 2. So it's where the two functions cross each other or intersect each other. Well, what happens when we don't have a calculator or the ability to use a calculator? Well, we have to find these manually. So how do we find them manually? So what does it mean to be an intersection of two functions? Well, it's where they're equal to each other. So if we are not given boundaries, so sometimes we are, we have to find them. So if two functions are equal, well, we can set up an equation. We can take the first function, set it equal to the other function. So 2 minus x squared equals -x, and then we go ahead and solve for x. Well, we have to remember our algebra here. So anytime you have an x squared term and an x and a constant term, that means we're going to try to factor some way, somehow. In this case, we can do it. So we're going to move everything to the right-hand side. So it's going to be 0 equals x squared minus x minus 2. Apologize, it's kind of hard writing with a mouse. So now we have x squared minus x minus 2. So we can factor this. We got to remember our factoring skills. So this one's a pretty basic factoring problem. Sometimes it'll be a little harder, so we have to remember, and we'll look at that throughout the year. So x and x, because of no coefficient out here, and factors of -2, so things that multiply to -2, and then we want to add to 1. So -2 and a +1. So those are equal to 0. Now we can use our zero product property and solve for x. So x equals 2 and x equals -1. Just like we knew they would by looking at the graph, but like I said, sometimes we don't have a graph or the ability to look at a graph. So these are going to be used as the boundaries. So now area between two curves is given by this. The integral of the top equation minus the bottom equation. So in this case, so we're doing blue minus red, or 2 minus x squared minus a -x. So let's write that out. So 2 minus x squared minus a negative, so that's going to be a +x, and then dx. So we got to throw our -1 and our 2, so we know what to evaluate at. Now we can integrate. So we could easily just throw this in the calculator and then find the integral that way, or we could do it by hand. So my suggestion throughout the course of the year is to do some in the calculator and then some by hand, just so you are keeping up on your integration skills. So now we look antiderivative of 2, that would be 2x antiderivative of negative x squared. So we have to remember raise a power. So 2 goes to 3, and then we divide by that new power. So divided by 3. And then antiderivative of x, we raise the power. So x squared, and then divide by that new power, so 2. And then we're going to evaluate from -1 to 2. So we talked the other day about the fundamental theorem of calculus. So we're going to use that to evaluate. So we know we start with the top number first, and then we do the bottom number. So we have 2 times 2, which is 4. I was debating on plugging it in, but I think you get the idea. And then 2 goes into x here, so x cubed is 8 over 3, so we're going to do 8, or negative 8/3. And then 2 goes into this one, 2 squared over 2, that's just going to be plus 2. And now we subtract the next grouping. So now we're plugging -1 in. So 2 times -1 is -2. Plug -1 in here, and -1 cubed is still a -1. So we have a negative. So that's plus 1/3. And then plug 2 into here, or no, sorry, plug -1 into here. So -1 squared is 1 over 2, so we have a plus 1/2. And now we can carry this negative through. So we have a 4, a 2, and a positive 2, so that's going to be 8. -8/3 minus 1/3. So that's going to be -9/3 or -3. And then minus, oh, I wrote a 2, but that's a 1/2. I apologize. I said 1/2, but I wrote a 2. So minus 1/2. I'm just going to write that there. So now we have 5 minus 1/2, so that would be 4.5 or 9/2. You know me, I like improper fractions over decimals any day. So 9/2 is our answer. And it's easy to use if you had to use this in a calculation later on in a problem. So that's it. So only 2 more examples. I want to try to keep the video short for you so you can do some work. So the next one, everybody's favorite, trig. So we have cosine of x and negative sine of x as our 2 functions, and we want to find the area between. I'm actually going to give you the boundaries. I meant to type it on here and I completely forgot. So let's see. Let's go 0 to pi over 2. Okay? Those are going to be the boundaries there from here to here. So top minus bottom, we have a top function of cosine and a bottom function of negative cosine. So let's go ahead and set our integral up. So we're going from 0 to pi over 2. Top function minus bottom function. So negative sine, that would be a plus sine because we're subtracting. Okay, so now we have to remember how to take the antiderivative of trig functions. So try to remember that if you take the derivative of sine, you're going to end up getting cosine. If you take the derivative of cosine, you end up getting a negative sine. So that should help us go backwards. So if I'm finding the antiderivative of cosine, that's going to be a sine. So sine x. Antiderivative of sine is going to be a negative cosine. And we're going from 0 to pi over 2. Now we need to evaluate. So actually I'm going to go down here and get a little more room. So sine of pi over 2 minus cosine of pi over 2 minus sine of 0. So I'm just going to change the signs right now. So sine of 0. And then minus a negative, so that's going to be plus cosine of 0. And now we just evaluate. So I know this is tricky for some of us. Some of us have to remember 2 years ago where you learned this in trig. Others, this is coming pretty easy too. But as a quick reminder, let me draw a little sketch over here. So we have, I'm going to draw our unit circle. Actually, I'm just going to make a circle here. So the unit circle, if we remember, that has a radius of 1. So this distance right here is 1. Okay. Now, pi over 2, that requires us to know radians. So as a reminder, our unit circle from here all the way around is 2 pi. So 1/2 of a pi is going to be actually a quarter of the circle. So we are right here at this coordinate for pi over 2. So if we think about this length being 1, and we remember the fact that our cosine value is an x value, and our sine value is a y value, we can easily evaluate sine of pi over 2. They're asking, what is the y value at pi over 2, which would be a 1. And then the same thing, cosine of pi over 2. What they want you to think is, what's the x value here? We all know that's a 0. Okay. I promise this will get easier throughout the year. We are going to work on this a lot. And I might even make a short video on some trig stuff. And then we have a minus sine of 0, so 0 radians. Now we're over here, this coordinate. This is still length 1, radius of 1. So the x value over here is going to be a 1, and then the y value, oops, I have that backwards. X value is 1, y value is 0. Okay? So now we can clearly see that we should have an answer of 2. Oops. All right, last problem. This one we have 3 functions. We have the root x, we have the x minus 2, and then we have the y equals 0. So actually, I just want to find the area between here. Okay? So some of us are looking at this and might see an issue with this. So if I look and want the area under that curve, so let me put that back. If I want this area, we're all good. If we start here, we can clearly see that these intersect at 0, x equals 0, and then we go all the way over here and we're intersecting at 4. Again, you would want to know how to put these equal to each other and solve for x, but we're just going to use the 0 and the 4. Okay, let's treat this as maybe like a graphing or a calculator problem. So as I go from 0 and I head over to 4, the issue is, oops, something's going haywire here. Let me get rid of this. All right. The issue is when we get to 2. So from 0 to 2 we're good, because the top function is going to be our root x, and then the bottom function would be y equals 0. So we're all good. Area under the curve until we get to 2, and then something happens. Top curve is still root x, but the bottom curve is now x minus 2. If you continue using the 0, then you're going to get all of this area down here, which we do not want. So you can do one of two things. You can set up an integral from 0 to 2 of top minus bottom, and then add on 2 to 4, an integral from 2 to 4 of top minus bottoms, and then put them together. We know we can add two integrals and get a good value. There's another thing that we can do. So we can look and do a situation to where we have a right minus left integral. And the reason for this is if you were to rotate this and make the y-axis the horizontal axis, we would have the blue function, or the x minus 2 function, be the top function, and then the root x would become the bottom function. So try to picture that. Try to tilt it 90 degrees. And you'll see that the right function, as it stands right now, becomes the top function. So it's still a top minus bottom situation if we do the right thing. What I mean by that is we need to switch everything in terms of y. So we need to be, so you would want to write this down in terms of y. I promise my handwriting is not normally that bad. So in terms of y, so what that means, we need to solve these. So let's do the right one first. And I'm just going to throw it right into my integral just to save some time. So the right function is this one. So if we solve for x, it's going to be y plus 2. Okay, so we just added the 2 over. And then we're going to subtract, if we solve for x here on the root, that's going to be a y squared. And then we have to be dy. And then to calculate this out, we need some boundaries. So not only do the functions need to be in terms of y, we need our boundaries to be in terms of y. So if we look at the y, notice we're going from 0 all the way up here to where they cross. Okay? So they're touching at y equals 2 and y equals 0. Alright? So we're running our integral from 0 to 2. And now we can just throw this in the calculator, because I said this was a calculator problem. Or if you want, you can work this out. It should be, if I'm remembering correctly, 10/3. So 10/3 should be your answer for this one. So that wraps up our video. So go ahead and try the problems I'm going to send out. And that should be it. And contact me if you have any questions, or talk to me in class.